I'm your host, Rosa Quinn. I serve as AECOM's Global PFAS Technical Leader, and what that means is that I strive to connect all of our PFAS practitioners all around the globe so they can share knowledge and support our clients by pooling our wisdom. And today I'm joined by three panelists, all hailing from AECOM, and so I'm really delighted to be here with some of my most treasured colleagues. So first, let me introduce Claire Mitchell. Claire is a program manager for a nationwide defense client in the United States. And Claire has, through that project, done PFAS evaluations in every state, and I think two or possibly three territories. Claire has 15 years of engineering consulting experience, and currently she is 100% focused on guiding over 30 PFAS remedial investigations through the CERCLA process. Um, and by the way, Claire co-founded AECOM's Federal Remediation PFAS Work Group, or what I call the Fed 5. Another panelist is Anthony Palmieri, or Tony as I call him. Tony is a licensed professional geologist and has provided technical direction on contaminated site investigations all over the United States. Tony has 18 years of experience conducting and managing investigations at U.S. federal sites, CERCLA sites, and he frequently serves as the lead scientist on these PFAS remedial investigations, some of which have fed us information that we're going to talk about today. And finally, I'm delighted to have Kelly Vosnakis join us. And Kelly is a senior human health risk assessor with 30 years of experience in CERCLA, RECRA, and state risk assessment programs, and is a lead risk assessor on a whole bunch of our PFAS investigative work. She coordinates best practices with all of the risk assessors at AECOM, and also has to shift that approach in response to the continually evolving federal PFAS toxicity information, clients' needs, and clients' programmatic guidance. So thank you everybody for joining. Let's go ahead and get started. We're going to talk about PFAS in the wild. And hopefully, through today's discussion, this group is going to help us understand where PFAS occur, where they might end up, how you track them, and of course, as I mentioned, how we define what is constitutes an unacceptable risk of exposure. So, Claire, I would like to start with you. Um, and I'm going to ask you a hypothetical. So, if a client called you up today and said, geez, I've heard a lot about this PFAS. I'm not really sure. Is it possible that I have some sites that I'm going to have to manage for PFAS? You know, what is it that you would learn that might make you think, they might
Mhm,
actually have some sites, or maybe we just already know where all the PFAS sites are. Yep.
mhm.
What do you think?
I mean, it's certainly a great question and is really fundamental to where you would start for any of these investigations. I do think it's worth noting my experience and my perspective on all of this is really rooted in PFAS investigations that are CERCLA style type investigations. So that really frames a lot of my perspective on this topic. So, to your question, when you're thinking about whether or not you might have a PFAS issue at your site, I'd like to think about it in terms of there are really three categories of sources that you would like to consider: primary, secondary, and tertiary. So in terms of primary sources, think manufacturing, AFFF use. I think those are really the two main drivers for a lot of the risk and a lot of the sites that are currently being investigated. In terms of secondary sources, you might be thinking more like biosolids applications or wastewater treatment plants, the effluent from wastewater treatment plants. And then tertiary is probably more ambient type sources, so atmospheric deposition from rainwater or simply use in consumer products. So in terms of where you want to start, you really want to focus on those primary and secondary sources. And for the most part, I think if you, really focus on those primary sources, you are going to know where most of your issues are. Um, and so in terms of, you've got your manufacturing and your AFFF use, I think probably the most complicating factor when it comes to AFFF use is for a very long time, AFFF was thought to be completely inert. So there was really no reason to keep track of where it was used, where it was released into the environment. And I think that's probably the single most complicating factor in a lot of these investigations is you might know that it was used or stored at your facility, but you have no idea where it was released into the environment. So that can certainly make things very, very complicated. So you kind of have to put on your detective hat when you're doing these investigations in order to figure out, where these releases are.
So
Um,
wouldn't most people argue, geez, firefighting foam, it was used at a fire training area, and then maybe, you could get a list of accidents or training exercises that happened. Are you saying that's not going to work for us for AFFF sites?
I think that's certainly part of it, but one thing that we've found that was probably the most beneficial tool in identifying where those sources are is interviews. I think it
Mm.
seems pretty simple, but finding somebody who has, been around at a given facility for many years and might say, oh, they used to do training at the end of that runway, or, we used to park our fire trucks over in this area. That is the information that is not going to be documented and it is really essential to, figuring out where these sites are.
So what you're saying is that sometimes these old timers or just anybody with a different kind of perspective can be coaxed into revealing some things they remember from their
Mm,
career or whatever it might be at the particular facility. Yeah.
mhm. Yeah,
Um,
absolutely.
AFFF use seems like a pretty common thing for us to, let me rephrase that. It seems relatively straightforward to connect the dots with where AFFF is used and where sites might be. Do you feel like there's some AFFF uses out there that have created sites that we really don't know about? I mean, is there more discovery there, or is that even a fair question?
So fair question. I think you would think traditional use of AFFF, such as, just fire training activities or use of
Yeah,
AFFF in an emergency scenario, that's really the only thing you're looking at. But we've done under the program that I manage almost 200 preliminary assessments, and we've identified more creative uses of AFFF that you wouldn't otherwise
right,
contemplate, such
right.
as using it for dust suppression, or even just storage on vehicles and then leaking from the vehicles, we found to
Mhm.
have caused pretty significant sources at several of our sites.
Well, with something as concentrated as the AFFF that would be in the fire vehicle, so before it was expended, that concentrate, it
Mhm.
doesn't take much to create a
Not-
source that raises a couple people's eyebrows, and we're going to get back to this concept of tertiary sources. I'm not going to let you off the hook with that because we are going to need to talk about this concept of ambient PFAS. But before we do that, I was kind of hoping maybe we could get a little flavor on Tony on. Okay, so this client has asked us this question, help us find our sites. Um, then you've got to do something. You have to approach this in an investigation fashion. And I was hoping you could maybe share kind of an overview, but also maybe any critical nuggets on how investigations roll. Are they easy? Is it easy to find a source?
That's incredibly difficult, as Claire mentioned. I mean, think of conventional contaminants like chlorinated solvents. Oh, there was a vapor degreaser here. We can, kind of trace that back. It makes sense. But with, firefighting foam applications, you know, training happens all over the place. And, it's difficult to always trace it back to an area. And when you investigate one, you may find others. It just kind of, it rolls in that way. It's kind of a unique circumstance with these compounds, I would say.
Yeah.
But, we as environmental practitioners have, many decades of tools that work. We know how other contaminants move through the environment. So using existing conceptual site models and, the science and technology that we currently have in place, that's really where you want to start with these things.
So
Uh,
are you telling me that geology is important?
It's incredibly important.
Right.
We are very much still learning how these things behave in the environment, but
Sure.
groundwater flow, soil deposition. I mean, we can use tools we've been using for decades to help it this and really move it further along. It's new investigation, but some of our old tools still work very well for
Yeah.
this.
Well, I mean, there is always an advantage to, I'm not sure everybody on the, attending today knows this term conceptual site model the same way that you and I and Claire and Kelly know the term, but really it's exactly what it sounds like. It is a model in your brain of the site and where things move. And that conceptual site modeling can be very simple, could be a super simple concept, and it can also get very elaborate. I would say at ACOM, we do everything from soup to nuts, right? I mean, I don't know. You've probably created, modified, developed, refined hundreds of these CSMs. So that's my guess.
That's the thing; they're always changing too. I mean, more information, plug it in, recalibrate,
Yeah,
use it to move forward.
be flexible. So when you know that there's a site, I remember in the olden days when I started, you'd be like, oh, well, here's a gas station. There's a source at this gas station. I'm going to punch a few holes in the ground. But I felt like we saw a slightly different approach with the PFAS questions. An approach, maybe you could talk a little bit about either Claire or Tony. I think I know you've designed some these so-called outside in methods of evaluating sites. Would you like to share that?
Mhm. Speak to that, Tony, if you don't mind.
Yeah, take a step.
Um, So what we found is an effective way to kind of work your way to find your source areas is to start at your facility boundaries, kind of between your potential receptors. You might have off-site, private drinking water wells. So start at your facility boundary and take a boundary approach. Figure out where it is at the boundary and kind of work your way back to the source.
Yeah.
Which has proven to be pretty effective in terms of for sites where you don't know where those source areas are.
Mhm.
So go between generally where you think it might be and your receptor and work your way back.
Yeah, and I would imagine that has the extra added advantage of uh, assuaging someone's concerns or spurring somebody into action,
Mhm.
right? Because if you are at a site boundary, which is closer to your receptor than the source, if you have kind of high levels of PFAS, then you're going to think differently about your next steps, I imagine.
Right.
So,
It's not going to take you a couple years or a couple mobilizations to figure out that you have an issue with it
mhm.
leaving the property. You would know that
Exactly.
up front.
So so an outside-in approach, especially in the early phases, um, serves the purpose of kind of reducing the amount of detective work you have to do, but also increasing the speed at which you can execute a temporary solution. And we are going to talk about those. But I think before we get there, actually, I noticed there was a question in the chat. Somebody asked, hey, if I go out on the internet, there are these maps that have sites of PFAS sites. Like if I want to look up a map of Europe, you can kind of zoom in and out. And the question was, how reliable are those sites? And I'd be happy to have this group chime in, but my understanding of how those were prepared includes uh, multiple factors. One is presumption that there's a site. So it's that thing in Claire's brain, aha, we might need to do detective work. A lot of maps put that site on there even before we know whether there is or is not elevated PFAS at that site. Then, of course, there is the regular reporting, for example, is required by the US Department of Defense or the Department of Energy. They have to share that information publicly. They work for us, right? Um, those data are there, but they don't always get there immediately. There could be a lag depending on um, how the map is constructed. And then the last thing is there might be things that aren't really sites, and so you have to just be a little bit skeptical, and you probably should consider any map, an interactive map of sites, as something that is a moving target or a living version of what we're trying to find out. But we do know a lot about which sites have the highest potential for releasing PFAS, and there's no reason for us to not appreciate the value of the information in those. Is I don't know how frequently any of you use those materials. I see them quite a bit in sort of public forums where people raise concerns, but I think with our client work, that's not that common. With the one exception that the EPA does have a very nice publication of PFAS data that they've collected, and if they can keep up with that, I think that's beneficial for us. Let's see. I was hoping we could shift gears a little bit and start to talk to Kelly about how bad is bad, right? And Kelly, I gave you that fabulous introduction. You've got this body of experience. When it comes to PFAS, what do we know and what do we not know about what constitutes an issue?
So that's, it's an interesting question. It's a difficult question when it comes to PFAS. There is a lot of data out there, and in order to, begin to come up with a safe level of PFAS, we have to look to various toxicity studies. There's studies in people, epidemiology studies, and there's more traditional studies using animals. There's lots of them out there for a handful of PFAS. As we all know, there's way more than we have data for, but I think we have toxicity data on kind of the worst actors, right? That's where people have focused their time and energy. And then we can use those toxicity values to calculate values that are considered safe or within acceptable risk ranges. And US EPA does this in their regional screening level calculator.
So
Um,
tell me a little bit about safe ranges, right? So you're telling me, oh, I'm just going to pick something like benzene. It's a
mhm.
component of gasoline. You're telling me there's a safe level of benzene in my drinking water?
Well, the premise of toxicology is the dose is in the poison is in the dose, right?
Right.
So
Mm-hmm.
um, it depends on how toxic the chemical is, but yes, we can. A lot of the benzene studies are based on epidemiology. We can look and see what has caused issues in the past, and the toxicity factors are developed so that you can calculate a cancer risk or a
Mm-hmm.
non-cancer hazard.
Mm-hmm.
So the hazard is going to be based on something that's going to say this is the safe level of this chemical that you can be exposed to every day for your life and not have an adverse health outcome be expected. And
So
for
an
cancer,
adverse
yeah,
health
like
outcome
heart
could be like
attack.
skin rash.
Yep,
Yeah.
yep. It could
Okay.
be skin, it could be cardiovascular,
Sugar,
any
liver, who knows? But
anything,
not
the whole
cancer.
system, the whole thing,
Right.
right, and not cancer. And cancer is handled differently where we calculate your probability of contracting cancer. And then EPA sets what they consider the risk management range or the acceptable cancer risk range of 1 in a million to 1 in 10,000. So those are the types of things that we're calculating the value in soil that would result in somebody not having a cancer risk greater than 10 to the minus 6 or an exceedance of a hazard index, usually of 0.1. We ratchet it down a little bit because there's
Mm-hmm.
usually more than one chemical.
Right. Right.
And
So you're
so,
telling us that there are really only a handful of PFAS that have that kind of information.
yeah, there's, I believe there's 7 or 8 that have final EPA toxicity values, and those are the ones that, the EPA at least feels the most confident in. And there's a few others that have been developed, more provisional values. There's a few on the horizon, but there's really only, I think about 10 or 11 that have final toxicity values that we
And
can
so,
really look at.
so would a regulator at any state in the US or even maybe in the Canadian provinces or elsewhere around the globe, would they use those final tox data too? Is that a kind of a
Well,
global
yeah, I
point?
mean, I think, EPA, a lot of people do look to EPA even outside the country, but
Mhm.
certainly other countries are coming up with their own numbers, and not everybody agrees with the numbers that the US is coming out with. They think, there are groups that feel that they're overly conservative and not really hitting the mark in terms of what's really a toxic effect and what's really a safe level.
Yeah. So, I mean, with a lot of science, there's give and take and even some cases controversy, but it sounds to me like for this handful, two handfuls, um, we have a pretty good idea of what the health impacts are.
Mhm.
That's what you're saying. So, yeah, tell me a little more. You were starting to tell us about the regional screening
Mhm.
levels, and there could be some people on the phone who've never used them, and there could be a couple of
Sure.
people who've used them all the time. And by phone, I guess I mean webinar, but you get the point.
Right.
Could you
Right.
maybe walk us in some baby steps through the RSLs a little bit, and remind us how Claire and Tony use those?
Sure. So they are calculated for several different scenarios, including, residential use. So assuming that you put a house on your site and there's a certain amount of soil that people are, you know, assumed to ingest incidentally throughout the course of their lives. So the soil RSLs are based on this residential assumption and protective of the resident for over a course of 26 years living at the same property from,
Hmm.
as a child and as an adult. Um, and then there's also a set for industrial. So if your site is not going to be residential, you might not need to reach those super conservative residential numbers. You can look at something that's safe for, say, an outdoor worker, a maintenance worker, somebody that might be doing groundskeeping, things like that. And then there's also tap water values, which are intended to be protective of drinking water. And these are purely risk-based, unlike the MCLs that take into account
Hmm.
treatment technologies and detection limits. The RSLs are purely risk-based. So a lot of them for these chemicals end up being lower than what we can actually detect.
So
So,
the RSLs in tap water for PFOA and PFAS, which I think most people are aware are PFAS that have MCLs or drinking water regulatory limits. Are the RSLs lower than the
mhm.
MCLs for
They're a
those?
lot lower than the
A lot
MCLs, a
lower.
lot lower. The tap
Hmm.
water, I have it right in front of me. The tap water RSL for PFOA is 0.0027 nanograms per liter. And for PFOS, it is 0.2. So
It
those are well below 4.
looks like Kelly is looking up to the heavens for her
Well, yeah,
RSLs.
I have all these things right in front of me most of the time.
All right.
Sure, you
So
reference that
yeah,
daily.
Yeah.
yes.
So that's a little bizarre. So what we're hearing is, and I think it's not that bizarre, maybe that's a bad word, but it's worth people understanding. The drinking water criteria, the compliance limits for drinking water include technology as a basis
Mhm.
for performance. But what you're telling me is that there is an RSL for those two compounds and some other compounds that are lower than our
Mhm.
laboratory detection limit.
Yep.
Claire, what does that mean?
Man, means a lot.
It means a lot. Yeah.
Where to start? So, I mean, that is a very important point that complicates things quite a bit. So there are a lot of kind of practical implications to these RSLs that we need to consider just from the perspective of somebody who's executing a whole bunch of these investigations right now.
Mm-hmm.
There are a few things at play here. First, I mean, the RSLs are updated every May and November, which, kind of puts you in this do loop of things constantly changing. You might have to go back and, reevaluate your data, screen, your data. And I think that's kind of a separate issue. But to the issue of the RSLs being so low, one thing that stuck out to me, I don't know, for those of you that attended the webinar a couple weeks ago, Ellie Ling mentioned um, an estimate that for every kilogram of PFAS released into the environment, it's estimated that it'll cost $1 million to remove it. And so what that translates to is, in order to clean up everything that's been released into the environment, it would exceed the GDP of the entire world. So that is kind of a mind-boggling perspective on all of this. So, that said, I do think that we as an industry kind of need to rethink our data quality objectives a bit when it comes to these investigations. Um, I
Yeah.
think we need to move away from being hyper focused on delineating to some screening level, whether it's the RSLs or some state values, and focus more on, what's happening at our points of exposure. And then also, like, what data do you need to be able to develop a good remedy to decide on what remedial action you're going to take? So I think that is the strategy that's going to be most effective in these investigations, getting away from the screening levels, focused on, minimizing risk and, getting the data that you need to do something about it.
Right. Well, taking action, especially when people have legitimate concerns about exposure, is much more appealing than these do loops, right? Where you think you're finally going to execute a solution and then you got to go back. You've added a PFAS. I don't know, Kelly. They seem to be stable now, but for a couple of those
Well,
rounds, they were adding them. What?
yeah, there's going to be more changes. PFNA will be final soon, and that's going to
Okay.
decrease that one. PFHXS does have a final toxicity value, but the RSL is still based on the old toxicity value, so that's
Yeah.
going to go
Okay.
down too. And the spring RSL update is delayed this year, so we aren't going to see that for a while. So
So, and we don't know when that's coming out. We just know it's
no.
delayed. Yeah. EPA administrator to kind of rethink the science that had been used for these PFAS regulations, for better or for worse. That's probably where we're at with those delays. And, I wanted to bring Tony into this conversation a little bit and ask the question. I mean, we've heard about how low these RSLs are, but if we step back out and ask ourselves, how are we making it more efficient to evaluate where sources are or where they're not? Are there tools that we can deploy in the field to do that, to make that happen more readily? It seems like that would be something we would enjoy having.
Yeah, I would love to have something similar to a photo ionization detector, or something that can do direct readings for PFAS. There are some technologies out there, that can do a handful of compounds, say PFOS, PFOA.
Hmm.
Not really at the part per trillion level that a lot of these
Okay.
investigations look for. Um,
So those might be adaptable to treatment systems that are handling really high concentration waste or something like that. Yeah.
Absolutely.
Yeah.
However, though, the labs, they're adapting to this very quickly, and we are getting lower detection limits. There's other methods like ASTM, D8421. Much quicker turnaround time. You can do a truncated list of compounds. It's fairly cost effective. You can run those on a couple day turnaround time, so you can get real time data as you're working in other locations to kind of keep investigations moving. Uh,
Yeah, and those are maybe you mentioned that, and Claire, I think you and I were talking the other day about
Mm.
an actual 1633 method that could have rapid turnaround. Am I right?
Yeah, some labs are offering, I've heard it be called 1633 light, which is
Like,
basically 1633 with some relaxed QC limits, maybe some
hmm
shorter analyte lists, rid of the kind of poor performers that require reruns that can slow things down. So, there are options to get that data more quickly. It's not necessarily real time, but it's near real time. So you can still implement these adaptive field strategies and minimize the number of mobilizations, really short down your investigation timeline.
Well, I mean, that is something that we've always pined for. I mean, I can remember when I was doing field work, doing testing for PCB levels in soil just way back in the day. right out there in the field. It was super helpful. But these very low limits are definitely creating what I would call, some additional challenges to our technological abilities to do this. That said, I am contacted pretty routinely by entities that are developing sensors, and there are many out there that people could look at and look at how they're developing into commercial products. Is on its own journey, and I'm not here to endorse or not endorse any of these. They really have to be evaluated how they apply to your project site. Taking you back to Tony's conceptual site model question, right? So let's keep that in mind. Um, so you know, we did get a question in the chat, and I wanna kind of loop back around to a uh, to a toxicology question, and then we're gonna move on and talk a little bit about background. So everybody, put on your thinking caps for that. But um, the question was, what do we know from epidemiological studies versus, well, and I'm paraphrasing, versus these direct toxicological studies? And, do we really have these population level concerns for PFAS? How is that entering into these data that we're using to set these RSLs? Sorry. Yeah.
So yeah, I mean, I see the question that popped through as well, and a lot of the epidemiology studies aren't necessarily of a population that was known to have had particularly high PFAS. They were set up from existing epidemiology studies where they could follow children from birth to age 5 to age 7. Not necessarily that this particular population had any higher PFAS, than anybody else. In fact, they think the levels are probably similar.
Hmm.
So and those studies do show effects, right? So you do see most of these studies were based on studying levels of PFAS in blood and levels of vaccine immune response in blood. And you do see sort of this inverse relationship where as PFAS levels go up, vaccine antibody levels go down. Um, but what we don't necessarily see is that there's an increase in infection, and that's what some other agencies
Mm-hmm.
have pointed out, that okay, so maybe the antibodies for diphtheria and tetanus are decreasing, but are we really seeing an increase in those diseases? And ATSDR, World Health Organization, National Academy of Sciences have all commented on this fact that while the effect is there, is it really eliciting that health effect? If you follow what I'm saying.
Yeah, and just for the gang, ATSDR slips right off your lips very quickly. But for other people, that's the U.S. Agency for Toxic Substance and Disease Registry, and it's closely affiliated with, if not part of, the CDC. I should
It's
know. My
part of the
sister was at
CDC. Yep.
CDC forever. So I
Yep.
just wanted to make sure that when you said ATSDR, people
Yeah.
could
Sorry.
go off and find that. Yeah, this is stuff that we do. We're pros. We're not. We're here using some of this technical language, and I am trying to make it a little bit more accessible for the universe. But that's just the way it goes. Let's see. And I think I saw one other question. Somebody was asking about a specific sensor, and I'm just going to have to reiterate that probably the best thing to do is to reach out to the different sensors or reach out to ACOM, and we can help you identify what might be best for your application. And it links back to things like ease of use, detection limits, action levels, and decision making that's going to be contingent on the tools at hand. But I am also very positively looking into the future that more than a handful of these field detection limits are going to be coming down the pipeline. So, you know what? So I'm looking at the clock here, and it seems like we've covered a lot of territory, but there is an area that really needs a little bit more explanation and discussion. So Claire mentioned this tertiary sources concept. This idea, we hear the term PFAS are everywhere. I sort of object to that. I would say PFAS are in a lot of places they shouldn't be, and they're in a lot of unexpected places. And as a consequence, we're kind of, here we are on the planet's surface, uh, kind of surrounded by PFAS sources. Some discussion of PFAS in rainwater, right? There was a very nice paper uh, produced on the topic of PFAS in rainwater, and I think Agnes is going to put that in the chat for us in a little bit so that other people can access that. What that leads to is this question of, okay, let me just back up. I've been babbling a little bit. Let me just back up. Okay, we have a site. We're concerned that there are PFAS there. We take some samples, soil, groundwater. Kelly's described how safe levels in soil are developed. Groundwater is considered, we're going to screen it against drinking water levels just to be super safe. Um, but if there's PFAS in rainwater, what the heck are we doing, right? We have, I, you can use the term background. You can use the term ambient. You can use the term anthropogenic, right? I mean, of course, PFAS are all synthetic, so they all are, based on human activity. So are there ways that this kind of ambient level can be used when you're performing studies of sites, you're evaluating where the PFAS are? Can you use that?
Loaded question. If you want me to take it
Tony, do you
first.
want to go? You go
Yeah,
for it.
I mean,
Maybe talk about background in general first, but go
sure.
for it.
Yeah, just with these, this convergence of these really low RSLs and these kind of widespread PFAS detections in soil and groundwater, it certainly complicates the ability to delineate, especially I'd say more so in urban environments where you have adjacent industry that could have air emissions, all kinds of contributing sources. It's it really it makes it tough. It has to be kind of on a site by site basis. And, a lot of states are leading efforts on doing background studies, which I think could be a huge help in, assessing local sites. But, it's an evolving science. I think the more data we get, it makes things more clear. But, an urban environment setting site may not be the same as, a pulp and paper mill out in the middle of, northwestern Washington with nothing else around it, kind of different setup.
Yeah. That's really interesting, that states have developed these background data sets, for lack of a better term. So what that is telegraphing, so these are state-driven studies. It's not like, I decided someday that I was going to characterize background in Iowa or something. That means that the states or state regulators or state maybe health agencies are interested in this, right? So if I'm doing a project in, I don't know, New Hampshire, where they looked at background levels. Kelly, that's where you live, right? Is New Hampshire?
No, close. Massachusetts.
Oh, you're in Massachusetts. For some
Yeah.
reason, I thought you were north of the border there. Yeah, New Hampshire went ahead and did this, and I think that can definitely inform whether the PFAS that you found at your site are from something that you can't extricate from the rest of the state. I don't know. Claire, any thoughts about that? What does
Yeah,
that
I
really
mean,
mean?
those state studies are going to give us a major leg up. And as a program manager and project manager, I can't help but think about the dollar and cents aspect
Okay.
of all of
Okay.
this. I can't help
Yeah.
myself.
Very good. Yeah.
But, background studies are really expensive. So to do one at each one of your facilities is almost a non-starter because
Mhm.
it's really expensive and the resources just aren't there to do that. So if we can lean on these state studies and other publicly available data to tell us whether or not we think that we will have a background issue at our site, and then combine that with the site data that you have, which will tell you, I either can or cannot find the edges of my source areas or my
Mhm.
plume. If you marry those two things together, I think, that is, the recipe for success for, the overall approach for your site.
Mhm.
So I think there's a lot of value in those state studies that, can help the all of us take a step forward with our sites.
I mean, when you think
Oh,
about it. Oh, I'm sorry. Go ahead, Kelly.
oh, so I was just going to add that, tacking on to what Claire said, I think that they're also going to be very important at the end of the day when we try to set up a cleanup goal. EPA
Yeah.
does not require that you clean up below background. And typically you have to do a site-specific background study, but maybe a little optimistic and hopeful that we'll start to see a little reality there that like Claire said, it's too expensive to do that, so we need to lean on these studies that have already been done. And if a state already knows that there's 2 ppt of PFOS in their water, that we're not going to clean up below that level. So I think that they will help us set a lower bound on those preliminary remediation goals.
I mean, we do this for a living, and we've become sort of attuned to a couple of phrases that maybe in the general public are a little bit less common, maybe even less palatable. So one of those phrases is acceptable risk.
Mm,
Kel- Kelly talked about um, even with compounds like benzene, a known human carcinogen, and the jury's still out on a whole bunch of PFAS questions. We have a tolerable limit in drinking water. Uh, it's low, and our goal is for it to be zero. As society
mhm,
in the U.S., we set the goal as zero. And for PFAS, we're setting goals that aren't zero. We're going to be setting some non-zero goals, and it doesn't really sound very good if you're some person out there and you're like, yeah, but you know what? These shouldn't be here, right?
mhm,
These just shouldn't be here. Um, so I'm not sure how what is it worth, right? That gets into a whole series of questions that are so complicated. What I will say, right? So what is it worth to clean up the planet? Well, there's going to be a range of opinions on that. But what we do know is um, there is a break point below which the costs are such that entities will take action, and the price point above which we will become paralyzed,
mhm,
right? So, Claire mentioned this kind of global holistic view that Dr. Ali Ling had talked about on our prior webinar. And then you can zoom in, you can look at the site itself and ask about that client and that adjacent site and those neighbors, right? Those are different judgments, I think. Those are
mhm,
just different. Um, Yeah, and so I mean, it kind of begs the question: are there some things that we can do that are a little bit less expensive that we can do right now, uh, or are we just going to create some harm by doing that? Um, Claire, I know that you've had some experience and looking at
Yeah.
just now solutions over just perfect solutions.
mm,
Yeah. And I mean, one of the phrases I like to say, maybe too often, is don't let the perfect be the enemy of the good.
Okay.
We're we're in this environment where the goalposts are constantly changing. We've got our screening level updates on a 6-month, frequency. We've got all of these factors at play. There's so much more we have to learn about the toxicological piece of all of this. But there are still things that we can do now that I think, and decisions that can be made now that are going to have legs to carry us into the future. And we
Mhm.
can feel confident that we're making the right decision. Um, one of the, something that we've worked on at AECOM was looking at all the EPA 1633 samples that we've collected for various clients across the US for both soil and groundwater. And we did a very, very simple analysis of the detection frequency in both soil and groundwater for the standard 40, or I think it's 44 now, but 40 analyte list
Mhm.
for 1633. And the results are really enlightening because the PFAS that are most frequently detected in soil and groundwater almost across the board are those that have current screening levels. So I think a reasonable takeaway or a reasonable conclusion you can draw from that is if you're taking action based upon those screening levels or those compounds
Mhm.
today, you're probably removing a lot of the risk and,
mhm,
inherently taking care of those other PFAS that we might not necessarily know that much about yet.
That is really a super excellent point. So let me see if I can digest that and reiterate. It's so important. I almost feel like asking you to say it again. What you're saying is when we look at project sites, there are a few PFAS, in particular ones for which we have tox data, that are almost always there. And if they're not there, nobody else is there. Few of the other PFAS are there at any, high rate of detection. So if we tackle these biggies, right, we physically get to that location where they are in our remediation strategy, we're going to be helping the community that's exposed to those, right?
That's
So
correct.
what that
Mhm.
does do though is it leaves this it's the donut, not the hole. It's the fringes of groundwater plumes, right? We've seen different rates of movement in groundwater of different PFAS, right? A um, you see the short chains moving out ahead of the main plume, right? So
True.
there would be some differentiation there, but you can get the big stuff all together, all at once, and make a difference. That's what I'm hearing.
Yeah.
Yeah, that's control. That
Yeah,
could
that
be
is
control.
control. Hmm.
Yeah, can control those known excess exposures. Certainly the exposures that exceed background, however that ends up being negotiated in the public or with regulatory agencies.
Yep.
And
Yeah.
you can
And
do
I
it
think
today.
absolutely. And I think when we're talking about control, we're not talking about, the actual remediation. That's our next webinar that
Okay,
if you
I
haven't
think
signed up,
so.
sign up for it.
Yeah, good
But we're
promo.
really focused on controlling the risk and controlling the exposure to
Mhm.
exposed populations.
Yeah,
That's kind of our definition of control.
and that gives the people who are living out here in this crazy world we live in a little sense of benefit. There is some way to control some of this before we get that ultimate, solution, whether it's to break every carbon fluorine bond or whatever it might be in between. So
Yeah.
that's
And I
pretty
mean, a
good.
lot of what we're doing now might just be heavily drinking water focused because that's often the
Okay.
greatest exposure that um, that certain areas might be facing. So it might look like, installing whole house filters or providing bottled water as a temporary solution or hooking them up to municipal water supplies. Those are all things that you can do now that,
Hmm.
kind of cut off that exposure to PFAS for those people, um, while you can continue doing your investigation and understanding the nature and extent of the issue. But you
Well,
can manage the risk in the meantime.
yeah, I mean, I love this. I mean, you and I have spoken, and many others have spoken about how this cadence of activity has been sort of problematic. We hear about PFAS, and then we hear about PFAS and PFOA. That's the olden days, and then we learn a little bit more about their toxicity, and then we got a few more PFAS. Right? Kelly talks about the updates to the RSLs. That's changing. Um, and by then you've probably already collected a bunch of information. Maybe you did all your interviews. Maybe you did whatever, or maybe you actually took some sample, and then you have to kind of go back and pick up these little, right, the do loop that you talked about. You think you're making progress, and then whoop, you got to go back. The regulations go up, they
Mhm.
go down, they change the compounds, they do whatever. And we took call it, flying the airplane while you're building it. That's
Mhm.
what we've called it,
Yep.
right? So, but what you're telling me is there is actually a part of this crazy airplane journey that we're on where we can tell people we're going to buckle you up and you're going to be a little bit safer, even if
Mhm.
we don't even know where we're landing.
Yep.
Wow, I took that metaphor all the way, didn't I?
I think I followed you.
Okay, well, it was probably terrible because it was done on the fly.
I like it.
Ah,
I like it.
yeah.
I'm thinking back to, so we started our first remedial investigation, I mean, the one that I started working on was back in 2018 when there were no soil values we were concerned with. And we were delineating to 70 ppt for PFAS and PFOA.
Right.
And
Right.
at the time we were like, wow, that's so low, that's impossible. And now we're talking about, a fraction of that. But I will say, those 2018 RIs that, we got started on a while back, we're now in the reporting phase, and our approach was a good one.
Oh, good.
We did our best to kind of insulate ourselves from those constant screening level changes and focus, on a data quality objective that, for soil primarily focused on hot spots. And for groundwater, for groundwater, we were able to delineate to non-detect. So that's not
Yeah, at
always the
that
case,
point.
but
Yeah.
for
Yeah.
for these certain sites, that was possible. But I think there are things that you can do to move your investigations forward. Even amongst all the shifting
Mm-hmm.
environment that we're working within.
That's a really good point too. Just think of like how fast that happened. Think of
Yeah.
RIs in the past that take 10, 15, 20 years. I mean,
Mhm.
glass has full. I mean, this is a big concern and problem for a lot of people, but it does, and push innovation and technology drivers, and really you know puts the fire to people's feet to do something about it. And I think it's pretty cool.
Yeah.
I
Yep.
I think that's a terrific comment. When we don't know stuff, we try to figure it out or create something that will fix it. We talked about the sensors. We didn't have them. Now we have a handful. Now we have a handful and even some that are commercially available. That didn't exist, 6 years ago when we were starting these sampling programs for the Department of Defense in particular, right? And in the meantime, we've done all sorts of very cool things as a community. We're going to talk about some treatment technologies next go around, but that has definitely, PFAS have definitely spurred innovation and the
Mhm.
treatment side. Do we have the silver bullet? Absolutely not. But do we have ways to control PFAS in the interim? Yes, we do. We have ways to control human exposure. We need to understand what that means before we actually do it in some cases. And in other cases, like Claire mentioned, the drinking water, you got to go for it, right?
Yeah.
If you are seeing this, out in the wild, then you collaborate with the stakeholders as a community to to execute a solution. Um, y- you know, um, let's see. I guess maybe I'm gonna just open it up and ask the group here of panelists, and we've gotten a few questions answered during this chat, so I'm glad about that. But do you feel like maybe there's a piece of advice that you might have about this concept of control? Have we covered it already? That's fine too. What any comfort for people in the area of control? Kelly,
I
are
mean,
we are we
yeah,
ever going to find out how bad all PFAS are?
yeah, I mean, I think that there's going to be a lot to come in the future, but I think, like Claire was saying with these 2018 RIs that we're getting to, we're at the point where I think we can look at some groundwater data and know if it's an issue. And like
Mm-hmm.
Claire said, I think it's really important that in those cases we take action now and don't wait for, the full RI to finish. I feel like PFAS is just a bit of a different animal than our legacy chemicals, and it's got to move quicker. So we know that these levels in groundwater are going to be above drinking water standards. Let's make sure that our private wells are safe or put somebody on drinking water.
Right.
You may not have to wait for the entire process because it will change. And it's particularly with groundwater, I think we really kind of know the answer, and it's probably one of the easier ones to control versus something like fish tissue where that's going to take a little longer if you have discharge into a surface water body.
Mm-hmm.
The control there is don't eat the fish.
Right, right, which
So
isn't very heartening, right?
no.
Um, um, I'm going to kind of re-ask the question, but I'm going to pull from this question we got from somebody, and it's like, well, how can you even talk about controlling PFAS and PFOA if they're so prevalent in background? Are we really controlling any of that? What is your take on that based on a site that has a PFOA or PFAS release?
Find the mass and go for it. I mean, again, look collectively at
it.
the bigger group of compounds, not just PFOA. Look at, the whole 40 or 44 compounds there. Look for the worst place and clean it up, and you'll probably reduce it significantly.
Mass
As an investigator,
reduction.
that's where I put most of my time and effort into.
Right.
Find the bad stuff.
I
Mass
mean, the
reduction.
background levels are going to be so much lower than a site-related level. You can see it. As you look at the edge of the plume, you can start to see, well, okay, maybe we didn't delineate here, but this is starting to look really sporadic and not
Getting a
anything
little
like the site.
fuzzier.
And
Yeah.
it just becomes pretty clear especially when you look at it on a map. It's like,
Mhm.
okay, this area is bad.
Yeah, and we know that tons of soil areas are impacted. We actually had a question earlier about biosolids, and we know that the soil around some areas, some sites with actual releases, the soil may also have biosolids, PFAS impacting. It's impossible to extricate the two of those. Well, not impossible. We do have forensics as a tool. Um, I hate to introduce a whole new topic here
I
at the
know,
end.
we need another 30 minutes at
We're,
least.
you know what we're gonna do? We're gonna do another webinar outside of our three-pronged approach, and rope in some of our forensic specialists,
That's a great
and
idea.
just people with interesting site data. Because honestly, I think there are a lot of people for whom PFAS are a big unknown. And then there are other people for whom there are some data that we have. I am actually going to share something before we get down here to the last little bit of our hour. Um, can somebody give me an audible that you can see a little slide here?
Got
I
it.
see it.
Got it. Okay. So, um, yeah, we're winding around to the top of the hour. First, I want to thank the three panelists for joining, but also for being such wonderful colleagues over a very long period of my career. So I am appreciative. Um, we have some general information about PFAS at AECOM at the first QR code link. It's a website. We do try to keep it up to date, but I can think of 2 or 3 things I'd love to add to it tomorrow. We have another webinar in this series. It's more highly focused on treatment from removal to destruction. And then if you would like to view the recording from the last webinar, you have to go to that link, and I may have to ask for our behind the scenes gurus for some additional strategic advice on how to get that to you. So, that's where we're going to land. I think that we've done our best to answer the questions about PFAS control. We talked about how do you find a site, what levels are safe, and what does that mean? Um, how much info do we have, and is it still moving? And then, of course, we talked about this consternation around background, like defining clean in the context of this anthropogenic source that is kind of coding all of us. Just it requires a slightly different way of thinking, a little more sophistication. So I'm going to leave that there. We hit the top of the hour. Thank you everybody for joining, and I certainly appreciate the time that you've spent with us. And thank you again. Thank you to our 3 panelists, Claire, Kelly, and Tony. Bye-bye.
Thanks for having us.
Bye.
Thank you all.
Thank you for organizing,
Bye.
Rosa. Bye.